Hello, and welcome to the wrap-up of the Cloud Analytics Tour, Uniting the Data Nation with Snowflake. I'm Matt Glickman. I'm Vice President, Customer and Product Strategy here at Snowflake. And the agenda for today is we're going to take you through a wrap-up. I hosted two of the sessions, London and New York. So I'll take you through what we went through in those cities and beyond. And following that, we'll have a live chat with Avi from the Chief Software Architect at Logitech, who will have lots of questions. He'll tell us about his experience with Snowflake and beyond. So with that, let's start with what is Data Nation. Data Nation is the combination of people, data, and applications, and what it means to bring those three things together in a modern data enterprise today. The challenge is that people in Data Nation are divided, right? There's this inherent conflict between the people who store and curate data from the people who analyze it, the people who secure it from the people who want to share it, the people who want to get access to the latest, newest data, and the people who need new data immediately. And lastly, the people who want to upgrade and manage the platform from the people who are inherently paying for and the business owners of this platform. So the question is, why are people in this Data Nation divided? And it starts off that they have different goals. If you look at the different people in an organization, typically, there's the application developers, there's the data scientists who want to have access to all the data and develop their models. There's management, there's different lines of businesses who want to have access to drive their own products and bring products to the marketplace. There's the BI users who want to be able to collaborate amongst their teams. And there's even QA and development who want to rapidly test and bring their products to market. And each of these different teams have different goals, and they're inherently at conflict. The next phase of what makes this Data Nation a conflict is data is disparate in most, if not all, enterprises. There's structured data and semi-structured or unstructured data. There's data marts for ops, there's data marts for sales, and each line of business has their own data marts typically. There's different constituents between customer data, partner data, internal data. Then on top of that, there's streaming data versus static data coming in at different cadences. And then on top of that, apps that people are building and running are the source of many of these problems, where the database can only support a certain amount of concurrency. These databases are expensive, and you have to price to the peak. Concurrency, and you'll hear us talk a lot about concurrency today. Concurrency is getting all of your users to access the data that you need to and to run these apps is critically important. How do you secure it? The specialized skills necessary, and then maintenance. How do you keep this running, and how do you make this not your primary focus, but meeting your customer needs is your primary focus? And then there's fresh challenges on the horizon. If that wasn't hard enough, applications are now moving to the cloud and in these kind of hybrid environments between cloud and on-prem. Then everyone's expanding into new markets. Everything is global, and new regulations are coming on the horizon as we speak. The next phase of interest and the next challenge is machine learning. Everything now is about being data-driven and using new and innovative machine learning models to get more insight about your customers and about your business. And lastly, there's this never-quenching demand for real-time insights, getting the latest data and not having to settle for old or stale data that doesn't reflect your current business. So ultimately, the people, the data, and these applications need a technology that connects this Data Nation globally. Thankfully, we wouldn't be here today talking about this if the cloud wasn't a perfect canvas to make these connections, right? It really became this great starting point to build upon. And Snowflake, with that in mind, set off, and we have been uniting the data nation in the cloud to solve these problems. So how can Snowflake help? How can we help unite the data nation? There's 6 different key tenets that we'll talk about. The first is being and what it means to be a complete SQL data warehouse. When you talk about providing access to this data nation, the most important thing that we find is standard SQL, the lingua franca of data, enables the most users to work with data without having to learn new skills. And having it be full standard SQL, full read-write, handling real transactions on real databases. People liked databases. People liked SQL. What they didn't like traditionally were the inherent limits and constraints and the expenses of that. But being able to speak standard SQL is a key component. The next is the broad ecosystem that this brings. Right? In addition to the people and skills, the tools you already have should just work. Right? There shouldn't be a need to in order to solve these problems of concurrency and solve these problems of getting the latest data at scale, of having to bring new tools. If the tools work, they should continue to work. The next is availability. This is the thing that once people have taken systems into production, they realize that when they're critical systems that their users and their customers depend upon, keeping this running is a hard task. And making this that it's just automatic, right? Data should just be automatically replicated. It should be backed up. It should be online. It should have high availability by default. It should have redundancy, right? These things should come built in. And lastly is security. Being able to have automatic encryption, to be able to have encryption keys managed and manage them yourself, and meeting the needs for the different regulations of security should all be built in and not something that has to be an add-on. So complete SQL warehouse is the first key tenet. The next is management. There should be minimal management to run a data warehouse at scale in the cloud. There's no excuse to have to tune infrastructure, optimize, and indices, and partitioning, and vacuuming. These are a thing of the past. It should just work. Next is all of your data. This is something that we hear a lot from our customers on, about not having to have a fixed, structured data set as their only data that they can get to scale from. Much data today comes in the form of JSON, Avro, XML, Parquet, in addition to structured data. These data sets should be treated as first class. You shouldn't have to pick and choose, and you shouldn't have to build data pipelines that just convert your JSON into tables and columns. It should be built in first class, and we'll talk about that in a bit. And this is at scale. Right? This shouldn't just be handling things at megabytes or terabytes. This should be petabyte scale. Right? We have many customers who have single tables that have multiple petabytes of data in them. Next is, and this will be a theme we'll talk a lot about today, is all of your users. The ability to have all of your users have dedicated SLAs. So in this picture you see here, there's 4 different groups as an example. There's SQL analysts, there's ETL and processing, there's data scientists, there's BI. Each of these groups should be able to have individual and segregated workload and segregated clusters of machines that don't compete with one another. They should all be able to be used at the same time without contention, with dedicated SLAs for each one. All without having to give up consistency of the data. Next is, as you'd expect with the cloud economics, you should only have to pay for what you use, right? Usage of any system varies, right? From the peak times to the off-peak times. Traditionally, for anything, databases or particularly data warehouses, you always had a price to the peak. You basically, whatever the peak was, that's what you'd pay for 24/7, and if the peak went up, you'd have to raise the bar and pay for that new peak 24/7. That's just not what people expect from the cloud, and you should clearly not expect that from your data warehouse in the cloud. So the ability, Snowflake enables this with true elasticity, where you pay only for the seconds you use, no over provisioning, no overbuying. As you need more, you spin up, and as you need less, you spin down. You don't have to think about capacity planning. We have many customers that during parts of the day shut off all of their compute, and during that time only pay for cloud storage, which is a pass-through from what the underlying cloud storage costs are. The next key tenet, and this is something that we are very excited and seeing a lot of adoption of, is the ability to get live data sharing. One of the things that the cloud enables is data can exist in this one referenceable space, the same way the internet does for websites. You don't download and copy websites, you point at websites. Same thing goes for data in the cloud age, is the ability to have data providers and data consumers have access, real-time access to one another's data, and be able to bring that data together without copying, without FTPing, but in a secure fashion with very, very granular security controls, but without copying. And this is the thing that we hear more and more about, is that as data sizes grow, it becomes even more impractical to move data around just because of the sheer volume and sheer size and magnitude of moving this data around. So having live data sharing, which is what the cloud can enable, allows different customers to bring data sets together without copying and having it always up to date and zero latency to be able to perform those operations. So what's the secret sauce? And this is something that we spent a bunch of time speaking about at several of the sessions. Right? What we said about up until now, this all sounds great. Right? Of course, you want unlimited elasticity. Of course, you want all of your users. But what has made this possible? The cloud alone was a great starting place, and these broad shoulders to stand on. But there were a few innovations that needed to be built on top of this cloud foundation to make this work. The first, and we'll talk about them in depth, it's the multi-cluster shared data architecture, a new architecture that took care of the cloud, take advantage of the cloud. Micro-partitioning, talk about how we store data to get maximum parallelization and extreme performance, and the benefits of a multi-tenant service. So first, architecture, and this is something we spend a lot of time speaking with customers. Before the cloud and before Snowflake came along, traditionally when you think about big data, everything was about this notion of a shared nothing architecture, where you basically would shard up your data into multiple, potentially many machines. And this solved the problem of large data size, where you'd have a piece of your data on each machine, and then you wanted to perform any operation, you would basically aggregate the data across all the machines. And this solved the data size problem, but it was not elastic. It was not pay-as-you-go. And most importantly, it didn't provide the notion of scale when it comes with many users coming at the data. Right? It solved the size problem, but not the user problem. And availability, clearly that, now you had many more things that could go wrong that could impact your availability. So when we set out to build Snowflake, we started with a brand new multi-clustered shared architecture a complete brand new database system from the ground up. We started with cloud storage. Right? This is the place that you can basically get very cheap, virtually unlimited amount of storage as a starting place, and be able to take structured and semi-structured data, as we spoke about earlier, as first-class data types, and putting that into flexible cloud storage for all kinds of data. On top of that, and that's the center, on top of that, we added the ability to spin up and spin down and resize virtual warehouses, which are effectively clusters of machines that do the work. They do the querying, they do the processing, they do the transformations, read and write workload. All of this can be spun up and spun down without having to get a copy of the data. Right? They point at the single source of truth of data that's been ingested into the system, and it's always up to date. And the way that happens is through this database services layer. So while virtual warehouse clusters can come up and down, and the data stays central and stored in cloud storage, this database services layer, which is really the third part of the separation of compute and storage, it's really compute, storage, and these meta-services. These meta-services are what maintains the current wavefront of who is allowed to see which data, which is the latest data in the system, and most importantly, what data and what is the for each chunk of each partition of data that's been ingested, what are the range of values that are in that piece of the data, so we know what is the minimal set of I/O we need to do to perform an operation. Right? There's no magic here. One of the things we talk about the secret sauce, and we're telling everyone about the secret sauce. The secret sauce on how you deal with scale and how you can scan and how you can work with multi-petabyte data and have sub-second response time is by not scanning petabytes of data. Right? You scan only the data sets you need to perform the operations you need, and that's what's maintained in the services layer. But the combination of the services layer and the separation of compute and storage allows these warehouses to come up and down, to get resized, always have the latest data, so that when any of these warehouses commit to change, the latest data is committed, and the next query in to any of these independent workload warehouses always sees the latest version with real transactions across tables, across databases. This was something that was thought of to be unheard of until this architecture came around. Now it's the expectation is, of course, you want to have consistency. Of course, you want to have a high availability. And of course, you want to be able to handle hundreds, if not thousands, of your users hitting this database at the same time and be able to scale up to not only to a cluster, but to an entire cloud region. Right? This is the kind of thing that modern enterprises are now not only had hoped for, but now are expecting in all of their workloads, and this is what we see more and more of. The next part of the secret sauce is micro-partitioning. As we talked about earlier, how we ingest the data into this cloud storage and how we represent it is as important as everything else we've been talking about. And the key is breaking data that automatically gets ingested into these relatively small chunks, typically under 100 megabytes chunks of each table, and having ranges of each table in these partitions that we can then move around very efficiently between the different nodes of a cluster. And then when changes need to be made to these tables, these partitions leverage the fact that the cloud storage APIs effectively are immutable. Right? So you store these partitions as individual files, relatively small chunks of a table. When an operation needs to be done to update and delete actual cells or rows in that table, That's supported through normal SQL, but under the covers, these partitions are changes that are made to a new version of these partitions with a new name, and the services layer is what maintains the current wavefront. So that if this chunk of the table, this partition, is the latest, you use it. If not, you don't. And this is what enables all of the parallelism, all the concurrency, is the fact that these partitions are small, are scalable, and under the covers are immutable. And the next part of the secret sauce is semi-structured data. We talk about semi-structured data. This is not just syntactic sugar. This is highly performant use of semi-structured data without having to first convert it into normal tables and columns. What Snowflake does is we introduce a new data type called a variant that natively supports JSON, Avro, Parquet, and XML, where that data gets ingested into one of these variant columns. As soon as that data is ingested, automatically behind the scenes, that data is virtual columns are created for every unique path in that, for example, JSON, to make it as performant to query it as if it had been broken down into separate columns, separate tables and columns, but yet it doesn't. So many of our customers are now feeding machine-generated telemetry or other kind of IoT data right into columns with no separate data pipelines for super low latency that they can start making decisions on right in the data. And even as the data changes in structure, no changes have to happen in their data pipelines. And the queries on it can be done literally by expressing the paths, queries on the paths themselves. And the last part of the secret sauce is what you get out of a multi-tenant system. First is no administration. Right? In order for the system to be workable, it's not like Snowflake has an army of DBAs to take that off of our customers. Everything's been automated. Everything's self-tuning. The architecture is designed from the ground up to be this way. Security is at the core. It's not an add-on. Everything's encrypted. Everything works the same. There's nothing to administer either by our customers or by us. Next is availability. Right? The system, in order for this to be fully automated, all the tiers have to be distributed and self-healing. All the systems have to be able to handle that. There is no good downtime. Right? You can have an outage for maintenance. Right? Systems have to be able to be rolled forward and rolled back without anyone knowing. Another thing that's interesting in the cloud, as in any data centers, is machines will break. Right? It has to be that this is seamless. Right? If a machine breaks, it has to be able to be automatically taken out of commission and replaced with others seamlessly without the customer having to do anything. We talk a lot about there being no knobs. If there's not something that you would do with that knob, there's no reason for a customer to have that knob. The only knobs that a customer of Snowflake has is how many different clusters, how many different virtual warehouses do you need at any moment in time, and how big should they be? Because that's the main thing that a customer knows that they can add value to, and that's a knob they should have. Understanding what it takes to repair a node that goes down is not something that a knob would benefit from, and hence there's no knob to handle that. And lastly is durability, right? The ability so that data is replicated across multiple data centers automatically for high availability. Right? This shouldn't have to be something that people have to think about, right? This is something that just should handle it so that, and if there's an outage, data should be automatically retained and be able to be recovered, again, automatically without having to think about it. Where are we going from here? So clearly one of the things that's great about working at Snowflake is getting the feedback from our customers and working with them and partnering with them. Almost everything we've talked about up until now is things that we've gotten insights from our customers and factor that back into the product. We continue to do that as we innovate for the future. The first is globalization. more and more of our customers are global by nature, working in different regions. This is something that we're investing in to be able to have. We already have Snowflake in many regions around the world. Having that work seamlessly so you can basically, your data can be wherever your users and apps are, and having that work seamlessly and be the same experience, in whatever region you're working in. Secondly is multi-cloud. We have many of our customers who have requirements to be on one cloud versus another, and we hear that, and we're working on that to have the same experience, be working on regardless of what cloud that you want to work on. We will work with our customers to work on those clouds. And tying that all together is replication, right? Multiple regions and multiple clouds is great, but you really want your data to move to where your customers are and where your apps are, and bring that data together where it needs to be. Replication is a big investment that we're making to make data move seamlessly around the world to where you need it to be to perform the business function that you need to. This is where our regions are today. This is the regions that we're adding across the world, and this is something that we continue to expand upon as our customers make new requests. The next focus of our investments going forward is real time. Right? This is something that it's always been a driver. There is no reason to have to draw the line between big data and real time data. It's all getting the latest insights on your data, and real time is where it's going. And this is something that we have over 1,000 customers today. Logitech is one of them. We'll talk with Avi in a bit. We have customers across industries who are either moving all into cloud, accelerating their BI with cloud, modernizing their platforms, finding new ways to build new analytics for machine learning along with their traditional BI reporting. Right? Data should be managed in as few copies and as few sources as possible, and should be able to get the most insights and the most value out of that data, and build upon this core foundation, these core gold bricks of what you get from a cloud data warehouse like Snowflake. So with that, let me open up. Avi is going to join us to talk a little bit about his experience at Logitech. So maybe Avi, if you can just quickly, introduce yourself, and then we can have a few starter questions that can get us going.
Hey, thanks, Matt. Guys, this is Avinash Deshpande. I'm the Chief Software Architect at Logitech. I manage overall solution architecture, platforms, and data provisioning for both CIO and CTO orgs. Right.
So Avi, maybe if we could start with a little bit of your experience. What drove you to Snowflake? What was the tell me a little bit about your deployment and what you were trying to accomplish, when you decided to try out Snowflake for Logitech.
Sure. So this cloud journey started a few years back. We've been on Oracle on-prem data warehousing for a while. Our charter was to make it cheaper, faster, proactive, have a footprint in cloud. So a few years back, we started the journey. We looked at different cloud providers. We went with AWS just because the ecosystem was ripe and had all the bells and whistles that one needed. We started the journey looking at spectrum of tools, Redshift being one, Vertica other one, and we went around kind of looking at different offerings at that point of time. We finally decided to look at Redshift as the next logical step for us. We went that journey into the cloud, re-architecting all the solution. We did asynchronous processing, moved the data the way we would do for a cloud processing. Started the journey fine, and then we hit some roadblocks on just the technology limitations. When, if you guys are aware of Redshift, the data broadcasting across nodes, and so performance was peaking, and then we had all those challenges with certain business use cases when you want to visualize business processes like the supply chain process and things like that. So we were still evaluating things. It did bring us way away from what Oracle Exadata solution was, which was a bit dated for us, to where we wanted to go, but we were not there at that point. So then came along Snowflake, and I was in one of these tours a while back in the city in San Francisco and looked at the technology, and we started a small footprint, played with the technology. Obviously, the benefits that Matt, you were sharing in the past were of interest to us. We wanted to still make it cheaper, but we wanted to scale beyond what we could do on Redshift as well, right? So then the Snowflake POC was done. We had seen 40 to 70% performance gains on a lot of payloads compared to even Redshift. It came down a couple of dollars per hour cheaper to what Redshift was. We had dedicated support. Those were the key benefits that you see. And then since we could make it proactive for the business loved the access to that. There were 0 Tableau extracts. We moved from 350 extracts every day to 0. It's all live as the data is made available and provision. People are getting to it. We do deploy multiple warehouses, so we don't have any resource contention, but we also look at a cost-sharing model to it based on these benefits. So we could put data science to go on their own warehouse, so we know exactly how it is being used and what does it cost us. We also provision different businesses to go on different warehouses. So that way we could provision for better capabilities and cost to it. The other benefit we've seen is to push payloads on different workflows. So even an upper management has its own dashboard going on a different warehouse. Maybe it's an extra large, but we don't keep it up and running for too long. So it comes down when the intent is done. We shut down the system for no activity of 5 minutes, even in production. It's an auto resume, but we essentially track. There is a dashboard which says how much is the usage to what does it cost, and we have that up and running in the hallway, and we know exactly what we're tracking against. So those are kind of the benefits why we went with Snowflake. We are running a big, the whole warehouse is already on Snowflake at this point of time, but we are looking at the capabilities which we didn't have in the past. And Logitech is obviously a hardware company. We have IoT devices all writing back data. So that the next use case obviously was semi-structured data coming from all of our logs from the devices, and we are provisioning that data into Snowflake for analysis as well as streaming analytics.
Wow, that's great. I mean, there's so many things I'd like to dig into there more. I mean, you really covered the spectrum of use cases and strengths. In hindsight, you probably should have gone first. But I mean, you touched on a lot of things there that were pretty interesting about everybody getting their own access to resources, upper management getting their own warehouses, no needs for Tableau extracts. I mean, can you talk about again a little bit more of like the impact or like that you're seeing in your organization on it sounds like, I imagine that this is not all just happening silently, like you're now able to do more things. But can you talk about like how you've been able to kind of unite your organization and the different things?
Absolutely.
I mean, there's so many things there, but just pick a couple.
Sure, absolutely. I mean, the greatest thing is the business loves the availability now. They don't have to wait for payloads to be made available. Job structures not refreshed. Come Monday morning, data not being available. Those are things of the past. The data is clean. It's easier access. We have enterprise-wide entity definitions now. So we have governed the process to where it's one object definition where people can get to it. So the silo-ness of data marts to the data warehouse to Excel sheets floating around is in the past. People are getting to the same information from different avenues. We are tool agnostic, and they could pick and choose whatever tool they want to use. So it's not Tableau specific implementation to an OBI specific implementation. So we moved away from those. So business can get to the data in real time. It's consistent, it's governed and secure. They can do much more. So we see a big plethora of teams trying to go beyond just the regular analytics and tactical reports and things like that. We're doing a lot of advanced analytics, predictive modeling. I've seen people trying to figure out use cases which they couldn't even try or dream of in the past. So that's kind of the traction where we got everybody together and got excited about the data being available. The data always existed. It just was not easily accessible, right? With what we can do on Snowflake in terms of performance and scalability, as well as on semi-structured data access. We also provision external information like Facebook Business and Google Analytics being blended with the data warehouse. So the capability-wise, we have gone way ahead in the game from what we had in the past. So that's sort of uniting everybody, taking everybody together. We are no longer like a support org. My team has been successful in getting it as a service org. So we actually understand how business uses the information. So then we could add more value. It's not just about pushing the data to business and go do whatever, right? So it's being more and more use cases being brought forth. People obviously had ideas, and that's what becoming a reality now.
That's great. And seeing people be able to have ideas they can try out on their own, that's just, and that's what I particularly love about, like, the whole per second billing that, the cloud providers, starting with Amazon, really got us going down the path of, and we were able to pass that on to our customers is, where you pay for the seconds you need. And so any question you want to ask, right, it's seconds of compute. I mean, it's pennies in effect to ask questions of your data that effectively are always hot. I mean, have you seen cases where there are things that people came up with that they wanted to work with data, or questions of the data that they could ask now that they would have not been able to before?
Absolutely. I mean, looking at the IoT use cases, we always had logs data which somebody would mine and figure out getting to the information and insight into it. Today, we do real-time processing as the data is coming from edge. We're using Snowpipe to push the information in real time. Obviously, the logs can differ, whether you are presenting a half an hour session to playing 10 hours of virtual reality gaming. All those devices will have different logs, different size of the files and the session. We ingest all that information into Snowflake. We keep it in that same format of JSON. So it's schema on read. So if there are changes being implemented on the hardware side, we still are able to ingest those and not fail. In the past, that was being put into a structure. So the moment you put semi-structured data into a structure, you have some intent of what the analysis looks like. So you've actually lost unknowns in that data at that same point, right? So that we moved away from. Now people could look at the unknowns, and maybe there's a use case saying, if there are issues with connecting to Bluetooth, I want to know how frequently they happen. Is there a possibility for me to push back something as a connected device and ensure the customer or the consumer has the best experience, right? These things were never possible, or you couldn't think through just because of the limitations of the platforms as such. We've moved away from that. So those use cases are actually on the forefront that I'm working on with my team now.
Oh, that's great. I mean, I love, nothing brings a tear to my eye more than the fact of where either questions couldn't be asked that people had, or data was thrown away and couldn't be used to answer it. And like you're saying, having this, particularly with devices, data that we're constantly finding new telemetry to add to these devices, be able to take the full fidelity and have that data accessible to you, all the time. And there's never a delay between having to change a data pipeline or change some kind of, converter. It's like if the device has the data, having that come in, and it's always accessible, and it can change over time. That's an amazing use case.
Yeah. You could actually think about certain use cases where a certain vertical has a thought about their own subject area, but what we also want to go beyond is how do we see as an overall business a 360 view of that, right? So we want to say how the device is performing. Does it impact how many times I lose a buy button on, let's say, an Amazon, right? So we sell products on Amazon. If there are challenges that I hear in the reviews on there saying it's a Bluetooth issue or connectivity issues, that would show up obviously in my logs, which I'm mining from the devices, but I would also see them in the retail websites on the reviews. So we do sentiment analysis on those reviews as well. So it will all tie in saying the reason I keep on losing it to a competitive product is because of these. So you could tie in a feedback loop going back to engineering to ensure that is mitigated at the root cause, and beyond that, our review should reflect a positive sign to it, right? So you're looking at spectrum of data points.
Yeah, and just being able to, that you always have all the data you need to begin to do an analysis, and you don't have to start every analysis as like, okay, where am I going to get this data from, right? The fact that now every new analysis is basically bringing together either a new data source that will be there for everybody else going forward, or you're building upon all the work that had been done previously. So now whatever data had been used is now available to all users for new cases that are coming. Obviously, with security constraints, as necessary, but basically streamlining every additive analysis is easier than the ones before.
That's correct.
That's great. So we have, and again, and I encourage anyone who's, for people who are on the phone to submit your questions. There should be a Q&A button you see on your screen. I see we have a question that's come in for Avi. So Avi, did you migrate all of your data extracts from Tableau to Snowflake? With a new capability added to Tableau of its own built-in engine, what would you see as the advantage of moving data and having Tableau pointing directly to Snowflake versus having to extract it out into Tableau server?
Sure. Yeah. So as I said, on the Oracle environment, we had about 350 odd Tableau extracts because we couldn't scale. Even if we wanted to, we couldn't get the live connections to scale beyond a certain performance gain, right? There's obviously complexity on the business data models that are being used. But hence, with Snowflake, we wanted to ensure we have the enterprise definition of objects and data models being created. We wanted to be tool agnostic because not everybody uses Tableau. We are not a shop where it's only Tableau only implementation. We have other reporting tools as well. And I wanted to ensure we have data consistency across platforms. So we were scaling it based on the enterprise assets where we have the business layer, and we expose. That's why we let business bring their own tool to the party, and Tableau is one of them. Obviously, Tableau wouldn't scale, so we had extracts with Snowflake. It's all live data, and we are able to scale the performance. And it's not that we are running like a huge warehouse on Snowflake as well. It's essentially a medium-sized warehouse, which comes and goes down as the usage is taken. If you guys are aware how Snowflake works, if you run a dashboard from Tableau, it's going to run that payload and then cache that data for 24 hours. So every subsequent call from Tableau for the similar or same information, it's going to just reuse. So then you're only using compute. So you could think about some paradigms where a CEO or a CTO dashboard, you could refresh that at midnight, and all they are going to do is just look at that information. It is static for the next 24 hours as such, right? So things like that come to your mind, and you could provision information depending on the need of the hour. But we've actually been successful in migrating all the extracts away from Tableau. We don't see a need for Tableau to do extracts. Tableau extracts are tricky. Sometimes, obviously, Hyper should help beyond, but the TDE, if it breaks, you have to restart. And you guys know how the processing is. Monday morning is always tricky. All your Hyperion cubes, your Tableau extracts, and something definitely goes wrong. So I didn't want this extra processing. If the data exists on Snowflake, why extract it again if I can scale the live connection? So that was always the intent, to move away from the extraction model.
No, it's the holy grail. I mean, it's the it's like the famous question. It's like the joke of computer science. There's only three numbers in computer science: 0, 1, and an n. And if once you go into copies, right, and you're going to have copies in extracts or data marts or whatever, right? It becomes difficult, if not impossible, to manage by minimizing the copies and not having to have copies of data and all being accessible in all one place. That it just makes your whole life easier. And then you have tools that all the tools are in sync, by definition. Can you talk? I'd like your answer. Can you talk a little bit about? You mentioned sentiment analysis and how you're doing that. With the data that you have in Snowflake. Can you talk a little bit about how you're doing that, and what kinds of integrations and how you've found that experience?
Sure. Yeah. So Logitech sells obviously consumer goods on all retail websites worldwide. We are B2B, so we have this multi-tier model where we sell in. So if you look at Amazons of the world, we have all those products there which Amazon is selling, and then you have a third party selling as well. We look at the pricing and the reviews of our products, sometimes competitors, to figure out what's going on with the products, and we run sentiment. So that base data of, let's say, reviews, for example, is provisioned from Snowflake, and we run. Today we have two different class of users. Some of them are R savvy, and then some of them are Python specific savvy guys from our data science teams, and they use those payloads to do the sentiment analysis, engine analysis. We obviously do word clouds and things like that to visualize what is being said about those. Sentiment analysis is a sort of a wide topic, but you pick the sentiment that would make sense, the keywords that would make sense for your business decisions to be made. We provision those information through Snowflake. In the past, people would take the data into their data frame if you are savvy in R. It loves this memory-intensive things, and it would take a while for them to trim their data frames and do the analysis. We moved all this away from them. We connected with those data scientists and ensured they do more SQL processing. So now more and more aggregations are being done on the engine, and then the data that's relevant to the usage is what they use, rather than trying to massage. So data science comes with the saying, you get the data baseline, you massage it to where it is usable. We take all that guesswork and the grunt work from the data scientist team and provision information or data based on the SQL power. So we could scale Snowflake queries really fast, so their payloads can be processed really soon.
No, that's great. And again, just data science and machine learning, these are just different tools and different frameworks and different techniques to get insights out of data. And just more and more customers, like yourself, it's great to see that these are not being seen as separate problems. One of the weirder kind of conversations we've had with customers is that they thought of us as being able to handle data warehouse problems, not machine learning problems. And ultimately, these are data problems. And the more accessible data is, the more that you don't have to worry about, the munging and mechanics of files, that just working with data at scale, focus on the questions and what they want to solve, the better. So it's great to see that you're seeing that impact as well. Again, Avi, I could probably go on all day about this. Your use case and how many of the capabilities you've already found a use case for and is transforming your business is fantastic. I truly appreciate your time today and sharing that with us. And I'm sure the people on the phone, I think hearing it from you is way more valuable than hearing it from me. So and from us here. So it's always great to hear from customers. And again, really appreciate it. Continued success, and we really do value the partnership.
Thanks a lot, Matt. I appreciate it.
Thank you very much, everyone. Thank you for your time.
Thanks. Bye.